A group of 12 pirates agree to divide a treasure chest of gold coins among themselves as follows. The kth pirate to take a share takes k over 12 of the coins that remain in the chest. So we want the number of coins initially in the chest as the smallest possible to make each number in the successive process be a whole number for each pirate to receive a positive whole number of coins. This is number 17 on the 2013 AMC 12A and the number 21 on the AMC 10A of the same year. Okay, so a strategy we will adopt here is working backwards. And by working backwards, we will be able to determine an expression for the first number, the first coin count before the first pirate takes, in terms of the number of coins before the 12th pirate takes. So call x the number of coins before the 12th pirate takes. Now, let's try to see how many coins there needs to be for the 11th pirate to take. Now, the 11th pirate takes 11/12, so he leaves 1/12. So x is equal to 1/12 of whatever the 11th pirate would take. So the 11th pirate would be x times 12 over 1 dividing by 1/12. Giving us 12x. And you can verify this is the case because the 11th pirate takes 11/12 of 12x, which is 11x, yielding 1x. Now similarly, the 10th pirate, he takes 10/12 of what he takes 10/12 of the share, yielding 2/12 for the 11th pirate to take. So if this is 2/12 of the whatever the 10th pirate has to take from, we can multiply this by 12 over 2 to obtain the number that the 10th pirate takes from. And if you continue this process, you will find that the first pirate has this many coins to take from. X, so I guess x times 12 to the 11th power divided by 11 factorial. And this is just applying this process. And to show where that comes from, you just take x, you multiply it by 12 over 1, multiply by 12 over 2, 12 over 3, as discussed in the earlier process, all the way to 12 over 11, and just making some notational simplifications, you would have that. Now, we want the smallest number so that this would be an integer, right? The smallest number initially that will allow each pirate to receive a positive whole number of coins. Right, so x is the number that the 12th pirate can take from. And the 12th pirate effectively takes 12 over 12, right, since he's the 12th pirate. So he takes all that remains. So he takes x coins. And if x is an integer, then we want this thing to be an integer. And if this is an integer, then all the successive amounts down the chain would be an integer. Now if you take this, and basically we want x to compensate for all the factors in the denominator of 11 factorial. The good thing though is we have 12 to the 11th to cancel out some of the factors. Cancel some. And if you work it out, there's a 5, 2 5s, a 7, and an 11 in 11 factorial that is not cancelled by the 12 factorial, and we need x to cancel them. And to cancel, we just we want the smallest possible, so that's just the product of all of them, which is 25 times 77, which you can work out to be 1925, which is D.